let's define independent events. So independent.
Do we need to take notes? Kind of questions.
Okay. So an independent event is when knowing the outcome of another event does not change the probability. I'll show you in just a minute.
So it's like it's unneeded information.
Something like that.
My pencil.
So knowing the outcome of one event does not change probability of another. The mathematical definition is this. That the probability of A given B is equal to the probability of A. The probability of B given A is equal to the probability of B. Let's talk about it. You ready to make a table? Okay, well, we're going to make a table. All right. Juniors, seniors, come on, there we go. Juniors and seniors, we give them the opportunity to watch either SpongeBob or
AHS.
Dora. They had to watch one of the two.
Man, Dora the racist.
Okay, so I talked to a bunch of juniors and seniors, and I surveyed 300 people. No. And of the juniors, 42 of the juniors said that they would watch SpongeBob, and 58 of the juniors said they would watch Dora. 84 of the seniors said they would watch SpongeBob, and 116 of the seniors said that they would watch Dora. So far, so good?
No.
Okay. So, given this, what is the probability that I select a junior?
1.5.
Oh,
That's
no.
It's 100 out of 300.
So we add it up. So we do 42 plus 58
It's 100.
over 300. So it's 1 out of 3. So the probability, the probability that I pick a junior is 1 out of 3, right? Okay, what if I only pick from people that chose to watch SpongeBob? So what is the probability of selecting a junior given that I know that they chose SpongeBob?
42 out of 120.
42 out of 126. Because I know that they chose SpongeBob, so they have to be in one of these. There's only 126 people in these two boxes. So the probability that I pick a junior, given that I know they chose SpongeBob, is 42 out of 126, which is 1 out of 3.
Wait, how? Did you get 42 out of 1? I thought it was 300.
Okay, the probability that you're a junior, given that you chose SpongeBob. There were only 126 students that chose SpongeBob. Right?
Okay.
So then I'm picking, what's the probability I get one person that's landed in this box? So it's 42 out of the 126. So far, so good?
Yeah.
Okay, so is this equal?
Yeah.
Yeah.
1/3, 1/3, right? That means that's this qualification. See, the probability of junior was 1/3. Probability of junior given SpongeBob was 1/3. So they're equal to each other.
Yes.
Right? Let's do it the other way around. What is the probability of SpongeBob?
126 out of 300.
Okay. Probability of SpongeBob is 126 out of 300, which simplifies down to how many? 21 out of 50. Okay. How did I know that? Have it in your calculator.
Oh, okay.
Okay. Or you divide by 6 across the board.
Oh, okay.
Right? Okay. What is the probability of SpongeBob given that they're a junior? So how many total juniors are there? How many total juniors are there? 100. How many juniors chose SpongeBob?
42.
42. And that equals 21 out of 50.
Oh, no.
So knowing what grade you're in does not help me determine what show you pick. They're independent of each other. And knowing what show you pick does not help me guess what grade you're in. They're independent. Right? Make sense so far?
Yes.
Let's look at it from the perspective of a tree diagram. Okay. Let's talk about, what are we going to talk about the probability of?
Sneezing.
Oh, 180 Saturday.
Okay.
Thank people.
All right, sneezing. All right, so. Do what? Okay. So we'll do sneezing and asking out.
Like asking on a date.
Yeah, asking a girl out.
So if you sneeze 5 times, the girl say yes.
So we watched. We watched all these guys ask girls out, and we determined if they sneezed and if the girl said yes or no. So those are the two things that we determined. Good? Okay. So, the proportion that sneezed and they got a yes. So asking out was successful. That was
Say 20.
Okay, so she says yes if it's asking.
Do what?
Can you sneeze while you exhale?
So that
Will
that's
you
pretty much
go out?
Yeah. So this was 10% of the time there was a sneeze and an ask out. Got it? Okay. Here, it was 10% of the time. So they sneezed, and the girl said no. 10% of the time. Good? Okay. They did not sneeze, and they got a yes. That was
Yeah, I'd be screwed.
50% of the time. And they did not sneeze, and they got a no. That would be 30%. Everybody have this down? Okay, because I'm going to slide over here, and I'll make a quick little tree diagram. Everybody starts out at this point, right? So there are two things that can happen. You can either sneeze or not sneeze. You could sneeze or you could not sneeze. And then, either way, you're going to have a yes or no. A yes or a no. So far, so good.
Yeah.
Okay. Here are my ending probabilities. So sneezing and got a yes. That's 0.1. Sneezing and got a no. It's 0.1. Didn't sneeze, got a yes. 50. 0.5. Didn't sneeze, got a no. 0.3. Everybody with me so far? Okay. What's the probability that you sneeze?
0.2.
Let's look at it. What is the probability that you sneeze? So, what's the addition of all the cats that had a sneeze? 0.2, right? So 0.2 goes right here. Right? Okay, so if there's a 20% probability that you sneeze, what's the probability you don't sneeze? 0.8. Okay, so this, if you sneeze, what's the probability of getting a yes? 0.1 out of?
Out of 1. Wait, what?
What? Huh?
0.2 out of 2.
Okay, so look, we've covered this concept before. Of all the sneezes, what percent of them got yeses, right? Now, when we do it with numbers, you guys get it real easy. Like on this table, that was no problem. But what's the difference in decimals? There's not much of a difference, right? So this is just, this right here is 0.1 over 0.2, right? Because it's this piece out of the total. And then 0.1 divided by 0.2 is just what? It's 0.5. It's 50% of the time. 0.2 times 0.5 is 0.1. Right, so the question was, how come we didn't multiply? Well, we kind of did. we undo it, right? 0.2 times 0.5 is 0.1. So what's the percent if you sneeze, you get a no? 0.5. So far, so good.
Yeah.
Okay. How do I figure out the probability you get a yes if you don't sneeze? Okay, so this right here is going to be 0.5 or 0.8. When you put that in your calculator, you get 0.625. Okay? Sure. All right, and so what about down here? What's the probability that you get a no if you don't sneeze? 0.375. So the question is sneezing independent from the answer you get? Does knowing that you sneezed help me to better determine what kind of answer you're going to get? Okay, does knowing that you sneezed help me determine what kind of answer you get? If you sneeze, there's a 50% chance that she says yes. Right? If you don't sneeze, there's a 62.5% chance she says yes.
Oh.
So these are not independent.
We should do a real study on this.
Did y'all see how that works?
Can we do a real study?
No, we're not doing a real study on this. But you can do it for your project if you want. That'd be a great way to do. For what? Okay, do y'all see how these are not independent?
Yeah.
Cheap fun.
I thought you meant like
We took that already. We took that.
No, my board stopped.